Welcome to chapter 5, where we're going to look at ratios and proportions. So a ratio, you may have used these before, especially if you're a sports fan. These are often used for sports statistics. You might use them for something like baking or for diluting chemicals. And so a ratio is a comparison of two numbers or like quantities. So you might have seen these written like this. So you might hear like there's a 5-to-7 ratio of females to males in a classroom, A to B with the colon, or A over B, which lets you know these really ratios are just fractions. You always want to write ratios in lowest terms, just like we do with fractions. And really, they are the same thing. It's just another way to express a fraction with like quantities. So if you were asked to express a ratio as a fraction, so if you were expressing 3 to 5, that first number is always going to be your numerator, and that second number is your denominator. So 3 to 5, another way to write that as a fraction is 3 over 5. 11 to 12, then, we could write as 11 over 12. If you were given a statistic, like the basketball team wins 17 of its 29 games in a season, the ratio of wins to games played then would be 17 wins to 29 games. Okay, or maybe you would write it like this, 17 to 29. Or you could also say 17 to 29. So those are all ways to express the ratio. Go ahead, pause the video, and try to write the ratio of the wins to losses for this team. Okay, and so wins to losses for this team, well, we know they have 29 games. So losses then is going to be 29 games minus the ones they won. And so we end up with 12 games that they've lost. So the ratio then of wins to losses is going to be 17 wins. 17 wins to 12 losses, or we could write it like this, 17 to 12. And we could even write in what it is if we want, 17 wins to 12 losses. Okay, so when we're using ratios to compare like quantities, we can simplify by canceling the units, which is basically what we've done above, where we're talking about sort of like games to games. So the ratio of width to length, by the way, in this shape, the width is always the smaller of the two dimensions. So our 7 centimeters is our width here. The 19 is the length. If we're asked to express the ratio of width to length, then that would be this over here, 7 centimeters over 19 centimeters. Because we have centimeters divided by centimeters, those cancel. And so we're just left with 7 over 19. If we were going to write the ratio of length to width, then that means the length is coming first. So we have 19 centimeters to 7 centimeters. We could cancel out those centimeters. And so we're left with 19 over 7. Okay, let's do another one where we have to simplify. So remember we said that we always want ratios to be expressed in the simplest terms, just like fractions. So if we're writing the ratio of 20 over 30 or 20 to 30, we would want to simplify that. So here we can divide both of these numbers by 10. And that'll give us our simplified fraction of 2 over 3. Another example, so a common size for a movie screen is 32 feet by 18 feet. So we've got 32 feet by 18 feet. The feet are going to cancel here. And then here you could figure out the GCF if you want to figure out what the greatest number, the greatest factor is. Here, it's a 2. We can divide both of those numbers by 2 to arrive at our simplified fraction of 16 over 9. So go ahead and try these next two on your own. Give this video a pause. Okay, and let's do this one together now. So we want the ratio of 24 to 32 inches. So we have 24 inches over 32 inches. We're comparing inches to inches. Our units are the same, so they can cancel. And then we want to look for the greatest common factor there. So let's do our chart just so we don't forget it. So we've got 24 and 32. So we can divide by 2 for 12, divide by 2 for 6, divide by 2 for 3. And so here are our prime factors for 24. And then 32, we can do something similar. So divide by 2 for 16, 2 for 8, 2 for 4, and 2 for 2. So here's our prime factorization for 32. So our greatest common factor, then we're going to circle everything we have in common. So we've got 2, 1 more 2, 1 more 2. So our GCF here then is 2 times 2 times 2, which is 8. So we're going to divide the top and bottom number by 8. If you prefer, you can just keep on dividing it down by 2 and you'll get the same answer. I just like, the nice thing about GCF is you know you've got it in simplest form. So we've got 24 divided by 8 gives us 3. 32 divided by 8 gives us 4. So this ratio then in simplest form is 3 over 4. Or we could write it like this, or we could write it like this. Okay, next one. So a common older computer display mode, these notes are a bit outdated, is 640 pixels by 480 pixels. So we want to write that as a ratio in its simplest terms. So we've got the first number is 640, and then we're dividing that by 480. So our pixels are going to cancel out. And then we've got 640 divided by 480. Well, I can see both of those numbers end in a 0. So I'm going to start right off the bat just by dividing by 10, which would give me 64 over 48. Now let's find the GCF of those two numbers so that we can get that in simplest form. So 64 is going to be a whole lot of 2's here. Okay, and 48, so we get 2 for 24, 2 for 12, also a lot of 2's. There we go. And now we're going to circle what we have in common. 1 pair of 2's, 2, 3, 4 pairs of 2's. So our GCF here is 2 times 2 times 2 times 2, which is 16. So I'm going to divide the top and bottom here by 16 then to get my fraction in simplest form. 64 divided by 16. I think that's 4. Is that 4? 4. 48 divided by 16 will give you 3. So your ratio in simplest form then is 4 over 3.